All clear, Abylay. Feel free to start whenever you're ready.
Yeah, I'm switching the slides. It's working fine?
Yes, we see the
Amazing.
outline right now.
Yeah, that's right. Yeah, amazing. So yeah, today the topic is decentralized identity. Here's the outline. So as we have different people from different backgrounds, I will provide some background on core concepts of DID, including DIDs, verifiable credentials, and so on. Then I will provide some brief background on decentralized identity across DLTs, including Hedera, Ethereum, and XRPL. After that, I will introduce benchmarking DID systems. It's a research project that we have completed recently, and I will share the results with you. So basically, in this study, we have evaluated different DID systems like Hedera, Ethereum, and XRPL, and conducted latency analysis, cost analysis, privacy analysis, which showcase like which implementation is best in terms of performance, cost, and privacy. And after that, we'll have a short demonstration. So I will show you how to create your decentralized identifier and updating your identity attributes using Hedera SDK. And at the end, we can discuss together some use cases for DID. So you can also share your thoughts on how this technology could be used. So first, what is identity and why it is important? Identity in itself is like more like not just technical. Like I mean, it's more like a philosophical concept. So it's a very complex and multi-faced concept according to the literature. In broader sense, it could be understood as a collection of characteristics, beliefs, values, and experiences that differentiate one individual from another. And it's also dynamic construct. And nowadays we have digital identity, which is very important part of our daily lives. We like everyone here is using digital tools and internet and so on. So we have our social media accounts, our personal data is all over the place. So yeah, so basically digital identity refers to the set of data that can be used to identify an entity within a digital system. In the literature, we have different terms related to this data. For example, identifiers. Identifiers were defined as a unique labels to recognize an entity like username, email, or user ID. We have then attributes, which are the characteristics or data points linked to that entity. And we have claims, which are statements one subject makes about itself or another. And these claims, like collection of claims, create a credential, which basically wraps these claims and used to prove the authenticity of these claims, basically. These are the terms related to digital identity from the literature. And as you know, like as we had internet over time, various digital identity models have emerged. Like there was an evolution of digital identity. The first model in 90s and early 2000s was like centralized identity model. Like we just had centralized identity model where user data was stored in one place. I mean, you create an account with some website and it's stored in that website only. And if it crashes, you lose everything. Like so, users basically in this model, in centralized model, users have little control over their data. So you rely on providers for security, privacy, and everything. Then in 2007-8, with emergence of some protocols like OpenID, we have federated identity model, which bring us some user-friendly things, like you can create an account and with one service provider and use it in multiple service providers. So, for example, like Google sign-in that we use still. So, but there are like some issues with this model. So the current model that we are relying. So in this model, identity providers can easily track user service usage and compromise privacy. And also security is only as strong as the weakest member in the federation, basically. And now, in recent years, we have a new model emerging, which is decentralized identity. Decentralized identity model is enabled by the emergence of decentralized technologies like blockchain or DLT, which providing the ability to eliminate intermediaries. So compared to centralized and federated identity models, control rests with, as you can see from the figure in the left side, the control in the previous models were with issuers and verifiers. So users had a little control over their data. But in the new model, decentralized identity model, the model shifts control to the individual user, so who can interact with others as a full peer. So, and the issuers and verifiers, they don't have to have direct interaction. So they can just rely on verifiable data registry, as you can see. And now I will explain some core components in this DID ecosystem, or technology framework. So as I said, like we need, for digital identity, we need identifiers. But for decentralized identity, we need decentralized identifiers, so which are globally resolvable. And importantly, they must be independent of centralized registries, identity providers, or certificate authorities. So we needed basically a new type of identifiers, and these decentralized identifiers emerged and was standardized by W3C. It's a standardization organization. It basically follows a URI format, like you have a scheme, method, and method-specific identifier. But what is the difference of DIDs and domain names? So this table basically summarizes it. They are both globally unique. DIDs are persistent. Domain names are reassignable. DIDs are machine-friendly identifiers. As you can see, like you cannot use this to identify yourself. So it's just it's just like in the technology-wise, it's independent of centralized registries. It's globally resolved, but it's for machine, not for humans to use it directly. So they are both resolvable. What else here? One important difference is maybe decentralized identifiers are fully decentralized namespaces without delegation. In case of domain names, it's hierarchical delegatable namespaces based on centralized root registries. So yeah, here we have centralized root registries on the top level. And DIDs are fully under the control of DID controller, while domain names are controlled by ICNN and the register operator for each DNS TLD, as I mentioned. So yeah, so DIDs basically, you can use your DIDs and attach your credentials, attributes into this, and use it for your identity verification. Basically, the concept is like that. But these DIDs are just like a string of ones. It's not just a string. So they are resolvable to DID documents, like a key value string. DID documents are JSON-based structures which contain more information, like more metadata that's useful. like public keys, verification methods, and service endpoints, which enable authentication, credential issuance, and other trust operations. So it's GIDs are much better suited and better designed for specifically for identity management. While in crypto we have like addresses like wallet addresses. Why not use wallet addresses here? Because they are restricted. They aren't suitable for all use cases of digital identity management. But here with DIDs, they are designed for this use case basically. So they are they are resolvable to DID documents which contain more verification methods and service endpoints. There, DID document is just a JSON LD document. I will show you 1 second in the next slide, I think. Yeah, the storage options, I mean, you can store, it depends on the design. So you can store it on chain, directly on a blockchain or distributed ledger, or off chain, which is more recommended. So you can store it in some database and just store the pointers in the on the ledger. Yeah, it's just a JSON document with some authentication mechanisms, public key material, a service discovery. It looks like this. For example, I should have interesting. Okay, so now we have DID methods. A DID method defines how these decentralized identifiers are created, resolved, updated, and deactivated within a specific system or network. Each method must specify procedures for core DID operations. So by DID operations, we mean like you create your DID, you should be able to create your DID, resolve it, like retrieve it from the blockchain or like from some database. Update, like updating attributes, service endpoints, and your public keys, or you can rotate your keys and so on. Revoke is like you change, you just replace your current attribute with updated one and so on, like or deactivate it, like sort of. So we have many active DID methods. You may assume DID method is like a specification for each blockchain or method, like how these operations should work and so on. So for example, because for Ethereum, we have several DID methods. For Bitcoin, for XRPL, and for Hedera, it's called DID Hedera. We also have for off-chain methods like IPFS, also web, DID web, which is like basically URLs. So, and also off-chain methods like DID-key and DID-peer here in off-chain methods like are more suitable for peer-to-peer use cases where, because they don't require any ledger to verify. And the second core component is verifiable credentials. So as I said, like we should have decentralized identifiers, and then we should also have some verifiable credentials, which are tamper-evident credentials whose authorship can be cryptographically verified. It's also defined by W3C organization. So I mean, it was standardized, so it's in the recommendation phase. Basically, in this, like in identity management, we have 3 roles. We have an issuer who issues a credential to a user or like holder who stores the credentials in his wallet, and he can present it to verifier by sending a verifiable presentation. And verifier verifies identifiers and credentials by checking and verifiable data registry. So which like verifiable data registry can like blockchain, it could be a verifiable data registry, or any other distributed database could be potentially a verifiable data registry. So now we move to decentralized identity on Hedera. In Hedera, it uses its Hedera Consensus Service for DID management. It's quite scalable and it's event based. So DID related events are recorded on HCS as metadata plus references, and full DID documents stored off chain. So basically, we have just hashes and pointers for retrieval. And DID method format looks like this. DID Hedera is a method. We have network, which could be like mainnet or testnet. Then we have identifier and topic ID. So basically, Hedera supports the full set of DID operations that I've mentioned, like creating, updating, revoking, and deleting, and also resolve. If you have any questions, you can also ask. Like, I'm not sure whether I can see your messages or anything, but let me check. Yeah. So yeah, if you have any questions, you can interact, but there will be a separate, at the end of the presentation, you can also ask, so that's also fine. So let's continue. Yeah, so as you can see from the picture, you can, like resolve is, you interact with Hedera mirror node and resolve your DIDs. But for creating, updating, revoking, and deleting your identifiers, you have to interact with the network. And on Ethereum, it's totally different. So it's built on smart contracts using the ERC 1056 standard. So I'm talking about ETHR DID method. So there are several methods actually on Ethereum. And here in this method, basically each identifier is self-controlled by its associated Ethereum address. So the cool thing with Ethereum is like you don't have to interact with a blockchain to create your DID. Your Ethereum address in your wallet is basically your DID. So you don't have to interact with the network and for registering your DIDs basically. But if you need to update some attributes and also use it properly, you will interact with the smart contract and pay some fee. There are many functionalities like account management functionalities on Ethereum because of the smart contracts. So you can delegate, transfer, control. You can also change the DID control to multi-signature wallets, so multiple people can control one identity, and also contract. So there are plenty of options provided by the smart contract capabilities of Ethereum. So yeah, the format looks like this. Basically, we have DID, ETHR, network, which is like mainnet or testnet names, and identifier, which is Ethereum address, or yeah, basically it's just Ethereum address. So it's quite simple and intuitive. Here, as I mentioned, like you can create your identifier by without interacting with your with the smart contract, but resolve, update, revoke, delete functions. These are require interaction with the Ethereum smart contract. XRP ledger. On XRP ledger, it's quite new. Like DID was introduced in October 2024. with the standard with the XRP ledger standard 40. In this standard, they have implemented DID functionality, like two functions. Could you mute?
Khalil, could you please mute the account?
Yeah. I'm gonna do it.
Yeah, it's a bit noisy.
Yeah. Yes.
Yeah, let's
I guess
keep
not.
muted. Yeah.
Yeah. Okay. Mute.
Yes, thank you. So because like there are like 60 people, so like please mute your microphones for now. So we'll have a question like questions at the end. Yeah, because it's a bit noisy. So basically, we start with XRPL. So in XRP ledger, like XRP ledger is they implemented DID like as a ledger native. So they have created two key transaction types, which are called DID set, which allows you to create and update a DID object, and also DID delete to remove your DID basic from. Format is like similar. It's just here uses network ID, like a number, like 1 for mainnet, for example, and so on. So that's so this is a table which shows the differences for each operations. One thing to mention here is about DID deactivation. You know that in blockchains you cannot delete anything. So like you cannot delete what you have already inserted, so it's immutable. So it's basically just deactivation. So we call it deactivate. For example, in Hedera, we've sent a new transaction, like generating a new event, which just nullifies and renders the DID inactive. So the like API will return to you like null or something, I think. In Ethereum, it's a bit different. In Ethereum, they have implemented it in a way that they set the controller to null address. So yeah, null address is like zeros, like only zeros. So if you set it to null address, you lose the control of your DID. So basically no one can do anything with that DID anymore because null address controls it. And there is no controller for null address. So yeah, so it's kind of smart. In XRPL, it's similar to Hedera. It's just a new transaction which deactivates the DID and reclaims the reserved XRP, it says. Yeah, so let's go. So yeah, in this part, as I said, like I would like to introduce some the recent work by me and Camille and Java from University College London and Exponential Science. So we have done a benchmarking framework for decentralized identity systems, which evaluates these DID systems So we will focus on 3 critical dimensions of system performance: latency, transaction cost, and on-chain metadata leakage, like privacy point. We believe that for real-world viability, DID systems must balance scalability, cost, and privacy. But there is not much work on this front in the literature, like systematic and empirical evaluation of these trade-offs remains scarce. So we have conducted a comparative evaluation of 3 widely recognized DLT-based DID reference implementations. The research questions we tackle here, like is, as I said, like performance, of course, and also architectural differences. And the main thing is like deployment trade-offs. So which platform, like which blockchain-based solution offers the most effective balance among these responsiveness, cost efficiency, and privacy for real-world DID applications. So that could be interesting to you. in this hackathon. So for example, if you want to integrate GID, which GID system you would pick based on your needs. If you so I will share the results and outcomes what we got from this research. So, but before let's talk about the methodology. So first we had to select the reference implementations. It was selected based on adoption and maturity, including GitHub star counts, repository activity, and basically like some developer activity and engagement from community and also from the team. So it should be active. That's why we have, and also the second thing we've looked at it was that these SDK languages for DID SDKs should be in one language because we are doing benchmarking. So to keep all aligned, we've selected JavaScript-based SDKs. Otherwise, for example, for Hedera, they offer two SDKs, one in Java language and second is in JavaScript, I think. In XRPL, it's the same, similar. So they have Python SDK and also JavaScript SDK. So for this study, we've selected JavaScript. And for the testnets, for Ethereum, we've selected Sequoia. For Hedera, it's Hedera testnet, and XRPL for XRPL testnet. And the metrics in this benchmarking framework are latency, which measures the time elapsed from initiation to completion of each DID operation. So we are, in this project, we've focused on just basic DID operations, so like that I've mentioned, like creating your identifier, updating, resolving, and so on. So, and tested it in terms of latency, cost, and also on-chain metadata leakage, whether it the last metric, private like on-chain metadata leakage, is about whether there is some fingerprintable information disclosed via metadata. Yeah, so that's also here. Yeah, we introduced a new metrics, which is like full cycle operation, which is the just composite metric, which aggregates the cost or latency. So it's very simple, but the relative latency and cost are quite interesting because they enable fair cross-platform comparison despite different block times and fee models. I mean, everyone here probably knows that Hedera is maybe faster than Ethereum. So it's pretty clear that Hedera will win if we just compare from latency points. So we have introduced relative latency and cost metrics for that purpose. So it basically normalizes operational latency by average block consensus time. So it's expressed, they are expressed as percentage of native block production rate or as overhead related to baseline transfer. So we've compared the ID operation fee to standard token transfer fee in Ethereum, Hedera, and XRPL. So it's like relative metrics, which gives you fair comparison. And in terms of tools, yeah, here what I can say is, so basically the experiment consisted of like 100 iterations per DID operation, and we have 5 operations. And the results for latency was like resolve operation was the fastest across all platforms because this resolve happens on off-chain, so it's intuitive and expected. For Ethereum, we have also create operation, which is off-chain, as I mentioned, so you don't have to interact with the smart contract, and that's why for DID create operation, Ethereum is the fastest. But for update, revoke, delete, it's in the range of 12 seconds, which is very in aligned with the block time in Ethereum. So which means basically from absolute terms, it's slowest, but it's very aligned with its block time. So SDKs, there's less overhead basically from SDKs and so on. In XRPL, we have 5.6, 5.8 seconds for on-chain operations. It showed stable performance and low variance. As you can see from the figure in the left, like in Ethereum, we have like a huge variance, high variability. Yeah. In Hedera, it's so Hedera basically wins on absolute latencies. It's fastest overall, and we have seen some variance, as you can see from the right side of the picture for Hedera. It's due to moderate SDK overhead. And what about relative latency, like compared to the block ledger's block consensus time? So as I said, like Ethereum aligns closely with block intervals, while XRPL and Hedera are showing like 37 to 50% increase. So which means there is some overhead due to SDK and also mirror node parsing and so on. So latency analysis showed us Hedera is the fastest, has the fastest execution. XRPL is best in terms of consistency, so it shows low variance and stable results. And Ethereum, despite highest absolute latency, it shows lowest in terms of relative latency. So that's interesting. The second part of analysis was on cost. So cost distributions. Here it's also like might be like trivial because Ethereum is like more expensive. But for Ethereum, like as I said, like there are two operations. Like you can create your identifier and resolve it for free. There is no cost. But for update, revoke, delete operations, it was like in the range of 0.06 with gas price of around 1 GVA, which was, I mean, it was for the last 3 months average gas price. But as you know, like in Ethereum, it might rise anytime. So depending on the congestion and demand. So this cost might increase exponentially. For XRPL, we have lowest fees basically, and it's flat and predictable. It's yeah, it's similar to baseline XRP transfer fee. Sorry, there is some mistake, and it shows 0 variance. In Hedera, it's also low cost and low variance, but it's higher than XRPL. And there is also, in terms of relative cost, it's a bit higher. So likely due to metadata addition in the transactional DID transactions compared to the standard HBAR transfers. Yeah, it's here. So sorry. So as you can see in Hedera, we have 150, 160% higher than baseline transfer. So there is overhead from JSON payloads and SDK formatting. But XRPL is the lowest, and Ethereum is similar to Hedera. So there is some overhead due to smart contract storage and plus logs. So the key findings from cost analysis is Ethereum most expensive as expected. And also it's also relative to its cryptocurrency transfer cost. It's also the highest. XRPL is lowest cost and perfect predictability. Hedera very low cost and moderate overhead. I mean, it's similar to Ethereum, so there is some overhead, but the fees are low. Here, design level analysis. I think I can skip this one. Okay, let's talk about privacy part. So in privacy part, we have introduced a new metric, which is called metadata leakage score, MLS, which quantifies privacy risk from on-chain metadata in DID operations. It's based on Shannon entropy of observable payloads and expressed in bits per operation. So basically, it assesses how the diversity and variability in the metadata of DID transactions. Higher MLS is more leakage, and lower MLS is stronger privacy. And what metadata includes? It's mostly about DID specific, like identifiers, DID documents that I've shown you, signatures, and also blockchain specific, like sequence number, block number, transaction hash, timestamps, and so on. We excluded like off-chain data here. I can show you in a while. 1 second. So for example, this is the example of Hedera DID transaction from the hash scan. Oh, sorry, it's not working. Why? Okay. So I hope it works. Yeah, it's here. So for example, this is like topic ID 0.067477667. And if you open the history, you will see your messages, DID transactions. So for example, this first transaction is DID create transaction. You can open it and observe the metadata. So it generates this metadata on chain. So like anyone, it's visible to anyone. So we have analyzed this privacy leak in this metadata, like whether there is like high diversity and any fingerprintable information available. So it basically, as you can see, it's like a date time, operation type, your DID, topic ID, some event, which is like encoded, and also signature. You can decode it like here. Okay, it's loading, it's fine. So basically, yeah, we are talking about this metadata, which is visible to anyone. And what we did, basically, we tokenized this JSON metadata for all transactions, for 100 transactions, and computed a Shannon entropy per token. Then we aggregated this by average tokens per transaction, which gives us metadata leakage score for each operation or like for each transaction. MLS assess the diversity and uniqueness of metadata content, as I said, and we did it for on-chain operations like update, revoke, and delete operations to be consistent with latency and cost benchmarks. And the results is like show that XRP, no, Hedera is again lowest leakage. As you can see, this like for each token, XRPL shows the best result, like 0.0023. But as you can see, they have like much more metadata available on chain, like 37 tokens per transaction. So because of that, when you aggregate it, it will less for Hedera at the end. So Hedera is like lowest leakage, Ethereum is moderate, XRPL is highest leakage. I mean, it seems like the numbers are pretty close to each other, but in the decentralized identity network, you will have millions of transactions because anyone like can create their identifiers, present, issue the credential, and present it, and so on. Like there is ideal like will be millions of transactions. So it these leakages could accumulate, and yeah, the total cumulative value will be like crucial at the end. So yeah. So basically, key findings are Hedera shows the strongest privacy based on this methodology. XRPL most verbose JSON payload, so it's a greater leakage. Ethereum is a bit less. So last analysis was on interoperability. Interoperability means like in this context, it means the ability of different DID methods and platforms to resolve, interpret, and verify each other. So, for example, you generate your DID and attach your credentials in one blockchain, but you should be able to use it in another blockchains or another DID methods. So basically, that's the thing. So we have qualitatively evaluated it, and this table is a summary of analysis, basically. So what it says, like the good thing is like all these three methods follow the same standard by W3C, which is good. Also, they are active in other standardization activities. For example, Decentralized Identity Foundation. I'm hearing my voice. So. Okay, so 1 second. Maybe disable. Yeah, could you disable your microphones, please? Okay, thank you. So yeah, it's just a little bit, like a few slides I think left. So then we'll move to demonstration. So basically what I can see is Ethereum has more active towards that. It has more cross-chain potential at this stage. It also supports universal resolver. In case of Hedera, it's also working on that front. There is a work with Linux Foundation and also with Hyperledger Areas, which is also decentralized identity framework. XRPL, it's still new, so it's a bit early with pilots under exploration. So conclusion. So we can conclude that Ethereum has highest latency and cost, but in terms of relative latency, it's showing good. And also there is like a very sophisticated account management because of smart contracts capabilities. In XRPL, we are seeing consistent latency and predictable costs, like lowest costs, and also here we are we see that in terms of metadata leakage, it's the highest. Hedera lowest latency, but I mean it's error, I think, because lowest latency is it's for Hedera, but in terms of cost, it's in the middle, but it's still low. It's highly scalable and repeat DID operations. Okay. So basically, recommended design pattern is like it's like a combination of all strengths of these DID systems. So basically, event stream architecture with fast finality and deterministic low fees, like XRPL. We should use constant size hash commitments on chain and encrypted content address DID documents off chain so that we will preserve the privacy. And DID system should support updates, key rotation, delegation, and recovery mechanisms like in Ethereum, so that users can control their identity in a flexible way. So let's try to do this demonstration quickly. How you can create your DID on Hedera. First, you need to look into this Hedera Hashgraph Decentralized Identifier Method Specification. It's this one, I think. Yeah. So this document, it's a specification. You should read it, which says how everything works in this in Hedera. Basically, it goes through the GID format, the operations, as I mentioned, like how create works, reading, updating, revoking, and so on, and also verification methods, what type of keys to use, algorithms to use, and so on. And also at the end, it gives you some security and privacy considerations. And we, for the SDK, you can use this Hedera GID SDK.
Talal, could you please mute this person?
Yeah, this
yes,
one.
Done.
Thank you. So this is the SDK. It's in JavaScript. There is another option for in Java if you prefer the Java language. So there are two options. This SDK is simple to install, and it provides you can create your identity network. You can generate DIDs. You can also, I mean, I will show you 1 second. I have this demonstration. So you basically have to clone this repository. Then you basically need to install this Hashgraph DID SDK with this script and build it once. So you do it just one time, basically. So it's done. We quickly install the JavaScript SDK here. So as you can see in the left side, so it's already installed. Now we need to build it. So for now, you can to interact with the blockchain, you need an account. So I would advise you to go to, for example, portal hedera.com and log into that one, and you should get your account ID and private key. It's a typical wallet address, actually. If you have other Hedera wallets like Hashpack and so on, you can use that one too. So you don't have to create an account here. So you basically need your account ID and private key. So you would interact with the blockchain and use this SDK to generate your DID. It's very simple. So I've where it is, this one, I think. Yeah, this one. So basically, I've registered in this website. I have my account ID and also this one in encoded private key, which I will use to create my DID. So in what stage we are? We have to build it, I think. Still loading. Okay, it's done. We need to build it once. Okay. So then after you generate your ID, you copy it. And in the demo file, you have this env file. So just go to the demo folder, and you have to put your own account ID in this operator field. and your private key in this operator key part. Yeah, it's a long private key. I think we can delete this part. Do not need. Save it, but you should also get rid of this example thing, so this will work. Okay, so ready. env is ready. What else we need to do? One second. So we built the SDK. We have created an account. We have replaced account ID and private key. Yes, we did that. Then, okay, cd demo folder, and we can already create. Okay, we are ready, I think. As soon as this ends. So there is already a prepared script for generating your DID. So it basically uses your private key and account ID from env JSON file. It sets up a client for testnet. So we are using testnet. It generates your it builds DID instance. So we are generating DID decentralized identifier. It's private key and public key. And at the end, it should print you your DID decentralized identifier and your public key. Basically, it's very small script. Let me 1 second. Let me just log into Hedera SDK so we can finally create this decentralized identifier. So go to demo folder, and it's a JavaScript. So we just run this script. Maybe it should work. Hopefully. Register. Yes. I don't know. Okay, let's see. Yeah, it's doing something. So it's subscribing to topic ID. So when you create your DID, it creates a topic ID, a separate topic channel for you, which you can use later to update and use your DID basically. So it says like your DID private key is this one, and DID public key is this one, and the basic identifier is this one. So it follows the same format that I've shown: DID, Hedera, testnet, and string, and also topic ID. So we should copy it and update this env file, I think, and just copy your DID private key. Okay. So it and also you can check your topic. It's referring to Dragon Glass, but I would prefer to use hash scan. So let's search. This is a topic we've generated. Messages. So there is one message, the DID create message that we did just now. So which says basically it's a as you can see from the Explorer, it's a Hedera Consensus submit message. It's very cheap and very quick. The cost is also very low. It's in line with our measurements, And if you click this message field, you can check the metadata, which is this one. Yeah, so basically we did it right. Now we would need to do like one more thing. We will update and revoke DID document core properties. For that one, we would use this an update and revoke service. Let's use this one. So here we use operator ID, operator key, and the DID identifiers that we have generated just now. And you set up your client similarly. You build DID instance again, and we are adding this service. Service endpoint is just a URL. Like for example, you can attach some URL to your DID. So for example, I put just it's just example.com, but you can link any domain, for example, and it would be shown in your DID basically. So let's try to run it. It should update your DID. So it's very simple. You click node add update and revoke. So we first update, then revoke. It's just service.js. So there should be two transactions here. First, you update your service endpoint. Then with the second one, you revoke it. So it's kind of complete. It would be complete. Yeah, so it's printing your DID document. So you can see like, yeah, service endpoint is here. So you see, we will check it from Explorer too. It's updated. Now it should be revoked. Yeah, you see, revoke, and so on. So two transactions. Let's check it from the Explorer. This one, I think. This is the topic ID, or which one is topic ID? Okay, this is the topic ID, basically. So just, you see, we have 4 transactions. Basically, we have updated the operation type is update, you see. So if you decode this event, you will see that we have attached. I don't know why this website isn't working. Load it again. Very interesting. Okay, let's try once more. Decode. It's very simple. Why it's taking so much time? Okay, we don't care. That's fine. So as you see, like we have revoke transaction here. Yeah, and you can check it from hashscan. Yeah, that's basically end of demonstration, but you can install this SDK and you can play with it, like generate your identifier in testnet. You can do it also on mainnet if you want to spend some money and create it. It's very cheap as our results show. So it's very cheap. And you can resolve and change DID ownership. It's already prepared demonstration scripts. Yeah, let's move to the next one then. I just wanted to give you some example of how to do it in Hedera, on Hedera. Now let's talk about the use cases, like business use cases, what we can do with this technology, basically. I mean, you can do many things, of course, but the most suitable, I think, we can. It's for DeFi and Web3 on-ramps. So, for example, we have Hedera Ethereum addresses. but they are like not verified, so there isn't any proof of identity attached to addresses. But some protocols might require like there might be some compliance requirements, yeah, to access some exchange or to access some staking pool and so on. In that case, you can use these verifiable credentials. So wallets with verifiable credentials, for example, can access it and prove their country and so on without centralized KYC, basically, which is great, I think. The second, what I see is cross-border identity portability, because these DIDs, I mean, anyone can create these decentralized identifiers, as I just have shown you. So basically, migrant workers, refugees, and so on, they could also create this sort of, I mean, the people who don't have passports and so on, like access to the traditional identity management, they can create, I mean, we can build some systems which allows them to create DID-based credentials and use it for some purpose, some specific use cases maybe. And also, in terms of like real adoption, we are seeing this ADAS 2.0 European Union's regulation, which and also European Union digital identity wallets are coming in the next years. They are relying on these concepts. So they are relying on verifiable credentials in some partly. They aren't using blockchain, but they are using verifiable credentials in the wallet reference implementation, which is great, I think. Because with blockchain there is some sort of issues that needs to be tackled, like for example this immutability, compliance with privacy regulations and so on. So there might be some questions and so on. So, but still, I mean, DIDs and VCs are being used in European initiatives already, so which is great. We can also, I mean, for DIDs have native support for zero-knowledge proofs. So, for example, Hyperledger Aries framework, they have support for ZKP. So basically, you can create some privacy-preserving KYC, as I mentioned before. So the users don't have to show all their credentials. They can selectively share their attributes, like I'm over 18 and so on. These sort of use cases might be interesting, I think. And also diplomas and certificates. Universities usually issue diplomas, I mean, as verifiable credentials. And it says it was adopted by MIT and some other universities in the world. So these are the use cases that I see, but please share your thoughts, like what kind of use cases are interesting and viable for DIDs. These are references. I can provide the slides to you, so you can later check that one. Yeah, now time for questions, or if you have any ideas, please share in terms of use cases. I'm not a business person; I'm more like research person. So the presentation was more like research based. But if you have any thoughts on use cases or any questions, please. Yeah, now it's time to ask.
Hi, sorry, I'm not sure if I'm doing this right. Do I just unmute and ask questions?
Yeah. You can do
perfect.
like that.
I'm going to be a bit cheeky. I've got like 3 questions to ask because I think I'm struggling a bit with the IDs. Firstly, I've got my API gateway implemented in Rust. First question is there a Rust SDK for the IDs?
For which blockchain, like, are you like aiming for a specific blockchain or it's not?
So I'm aiming for Hedera, but I can see the SDK is in JavaScript. I was wondering if there was another one for Rust.
Oh yeah, I see. So for Hedera, I think there is no Rust SDK, unfortunately. There is like two options, Java or JavaScript, but for other DIDs, there are Rust-based frameworks. But I mean, you are aiming for Hedera, so the answer is like, I don't think, from my experience, I haven't seen it.
Okay, and my last two question is, because essentially what I'm trying to build is like a layer 2 decentralized electronic health record. Now, I know you showed the DID template and how it's tagged with DID and then Hedera, and then there's like a hash there. My question is there a way to like add like another prefix by default with the SDK, or is that something that I would need to write like another middleware function to handle that?
I mean, if you want to add something, I think you can do it in SDK too. I did it once, so I've changed something in SDK, some fields, and it worked out. So I think you can try that one, I think. But ideally, like, it's not very interoperable, so for proof of concept, but it should work.
Okay. And my last question is in terms of the storage of DIDs. I'm not exactly sure what the drawbacks would be if I decide, because essentially it's more like healthcare sensitive data. So this is more like a professional advice kind of question. Would you prefer like using HFS or an IPFS solution, or like a hybrid solution that uses both?
Well, as I said, like for the storage part, it totally on your side. Like, you can design it as you wish based on your use case. And as you said, like for healthcare data, it's very sensitive, and to be compliant, you need to check all requirements. Yes, so I think I would say just go with what your use case needs. Like, just revise your requirements, and based on that, you can maybe just store it in some database, like, which no one can access. I don't know, like, sort of.
Okay, thank you very much. Lovely lecture.
Yeah, thank you.
Hello.
Yes.
Hello.
Who is talking now?
Hi. Can you hear me?
Hi,
Yeah. Please ask your question. Yeah, I can hear you.
Okay. I just want to clarify for the hackathon and for DIDs creating, we are working with keys, private keys, public keys. Can we just save them to like files for now for like proof of concept stuff and for the hackathon? Because I've been thinking about key management, especially when working with Hedera, when working with DID. So what's your, like the example that you did also, there's no way where, I'm not sure you showed where they were saving the keys, the credential keys, the private keys and public keys. So that's just my question.
Yeah, that's a good question. Like, for keys, I think you need you need to create an identity word maybe for that. Identity word is basically storing your DIDs, your key, verifiable credentials, and so on. So I would say, yeah, I think it could be done. Like, probably you need to create like a separate wallet for that, like identity wallet, where you can store that, and also you can also implement like more complex key management schemes like social recovery and so on. So like, there are plenty of options in Hedera ecosystem. I think there are many things are lacking. So you can innovate in that sense.
All right, thank you.
So, okay, I can see Sulaiman.
Hello.
Yes.
So thank you very much for a wonderful presentation. We really learned a lot. Mine is just a question about, can we get a slide for further reading so that we can go through and read more about?
Yeah, definitely. Like in a short time, I mean, I've quickly went through the concept. So if you want to revise and also see the demonstration again, I will share the slides with organizers, so they will share with you.
Yes, sure.
Okay.
Also, the recording of this session is going to be shared with you on Discord as well. So make sure to be present
Okay,
on
so thank you very
on
much.
Discord.
We really appreciate it.
Yeah, thank you. Well, if you don't have any question, I think we can wrap it up. Thank you very much for coming to the presentation. I will share the slides with definitely with you. And if you have any questions, you can find me in the slides. I will add my email, so you can ask specific questions regarding the IDs. I might answer it in email. So because I see that some of you are creating some proof of concepts using the ID tools. So if you have some specific questions, I might help you on that one. So I will provide my email in the last slide. So you can message me there, okay?
Okay, so thank you.
Okay, thank
Yeah,
you.
sure.
Thank you, Abylay. It was a great
Thank
session.
you,
have a
Abylay.
Thank
great
you, everyone,
week,
for
thank you.
attending.
It was a lovely presentation, so thank you.
Good luck with the hackathon.
All right.
Yeah.
Thank you. Thank you.
Thank you. Thank you, and have a good day. Bye-bye, guys.
Thank you.
See you
Thank
on
you,
the
Ziman.
next
Good luck.
session.
You
Bye-bye.
too.
Bye-bye.
See you. Merci. Shukran.